And we're back into 9.2, still naming and writing formulas for ionic compounds. In this podcast, we're going to show you how you can write the formulas from the names. And it's just the reverse from what we did before. When you take a name, such as this first one here, potassium iodide, okay, what you want to do is you want to write down the individual ions from the name and then crisscross the charges. Remember, the name of the formula is simply the cation name, anion name. Well, what is this cation? Potassium. It's K with a +1 charge. It's got a +1 charge because it's in the first family, which is the alkali metals. Iodide is I minus. So when you take K plus and I minus, you're going to get Ki. Crisscross the charges. With barium nitrate, barium is Ba2 plus. Nitrate is NO3 1 minus. When you crisscross these charges, the numbers anyway, the 1 goes with the barium, the 2 goes with the nitrate, and so you're left with Ba NO3 in parentheses 2. The 1 went with the barium, the 2 went with the nitrate. With sodium hydroxide, sodium is Na plus 1. Hydroxide is OH minus 1. Plus 1 and minus 1, you only need one of each, so it's simply going to be NaOH, sodium hydroxide. Again, if you think you're getting the pattern on this, go ahead and pause the podcast, try a few, and then start it back up. See if you're right. Iron 3 oxide. Iron 3 is Fe3 plus. The oxide ion is O2 minus. Crisscross the numbers. The 2 goes with the iron. The 3 goes with the oxide. You have Fe2O3. 2 irons, 3 oxygens. Fe2O3. Copper 2 sulfate. Copper 2 is Cu2 plus. Sulfate is SO4 2 minus. A plus 2 and a minus 2, they already reduced to a 1-to-1, so it is simply CuSO4, copper 2 sulfate. Hydrogen peroxide. Hydrogen peroxide is the stuff you buy in the brown bottle. It's an antiseptic that you pour on your cuts. Hydrogen is above the alkali metals. It's a +1. Peroxide is a polyatomic ion where it's O2 with a 2 minus charge. The 2 goes down with the hydrogen. The 1 goes down with a peroxide, so in this case it is H2O2. Now here's a case where you do not actually reduce this 2 with this 2, because technically speaking this is in parentheses with a 1 behind it, so you're not going to reduce this 2 with this 1. When you're using polyatomic ions, you always leave the subscripts alone that go along with that polyatomic ion. So we simply write this out as H2O2, hydrogen peroxide. Next row. Iron 2 dihydrogen phosphate. Looks like it's long, but again, just piece it together. Iron 2 is Fe2 plus. Dihydrogen phosphate. Look it up on your table. Dihydrogen phosphate is H2PO4 with a 1 minus charge. So the 1 goes with the iron, the 2 goes with the entire dihydrogen phosphate, so you're left with Fe1 H2PO4 in parentheses with a 2 behind it. Iron 2 dihydrogen phosphate. There you go. Impress your friends with that one. Sodium sulfite. Sodium is a +1. Sulfite is SO3 2 minus. Sulfate is SO4 2 minus. Sulfite would be SO3. The 2 is going to go with the sodium. The 1 will go with the entire sulfite. And you're left with Na2SO3. You do not need to include the parentheses with a 1 behind it. 1s are generally left off. Sodium bicarbonate, which is baking soda. Sodium is a +1. Bicarbonate is the same as hydrogen carbonate. It's HCO3 with a 1 minus charge. The +1 and the -1 means that you only need one of each. So you have NaHCO3, sodium bicarbonate. Scrolling down. Ammonium dichromate. This is good stuff. Ammonium is NH4 plus 1. Dichromate, Cr2O7 with a 2 minus charge. Crisscross the numbers. The 2 goes with the entire ammonium. The 1 goes in the outside of the dichromate. So you have NH4 in parentheses 2 Cr2O7. That's a little bit more complicated, but it's still the exact same rules. Potassium permanganate. This is a purple solution. Potassium is a plus 1. Permanganate is simply, MnO4 with a 1 minus charge, so you need 1 potassium, 1 permanganate, so it's KMnO4. Potassium permanganate. And finally, sodium hypochlorite, which is in bleach. Sodium is a plus 1. Hypochlorite can be written as OCl minus or ClO minus. This is more common, writing it this way. And so it's a 1-to-1, so it is simply 1 sodium, 1 hypochlorite ion, NaOCl. That is how you go from names to formulas. You don't automatically, unless you've worked with this stuff over and over again, you don't necessarily know what the formula is going to be just staring at the name. You want to write down what each individual ion looks like, crisscross the numbers, and then reduce. Okay? In the next section, 9.3, I believe we're going to be looking at covalent compounds, but this concludes 9.2.